Alright, till now we have seen different operations on CircularDoublyLinkedList, and we have learned what is the time and space complexity for this operation. Now in this video, we are going to put all of them together to see the entire picture of time and space complexity for CircularDoublyLinkedList. So let's get started. Now the first operation is creation of CircularDoublyLinkedList. Now we know that when we are creating a CircularDoublyLinkedList, we are just creating a node and assigning the value, and we are updating previous and next references of this node to itself, and we are setting head and tail to this node. So this operation is not time consuming operation, so that's why it takes one time complexity. Now as we mentioned, we are creating only one node in our CircularDoublyLinkedList, so that's why it takes one space complexity. Now when it comes to insertion in CircularDoublyLinkedList, we said that we have three cases. So we can insert an element at the beginning of CircularDoublyLinkedList, we can insert an element at any given location in CircularDoublyLinkedList, and we can insert element at the end of CircularDoublyLinkedList. Now when we are inserting element at the beginning and at the end of CircularDoublyLinkedList, it takes one time complexity, but when we are inserting an element at any given location in CircularDoublyLinkedList, it will take n, because in this case we have to loop through the CircularDoublyLinkedList and find the specified location. Now when we are calling insertion method, each time we are inserting only one element in the memory, that's why it takes one space complexity. Now then the next operation is searching operation. So as we mentioned before, here we are using linear search. So linear search means that we have to visit all elements of CircularDoublyLinkedList and check that if this is the element that we are looking for or not. So if this is the element, we are stopping over here, otherwise we are continuing to loop until we reach the last element. Now in the worst case, if the element that we are looking for is located at the end of CircularDoublyLinkedList, so this means that we have to traverse all elements until we reach the last node. So in this case, if the number of elements in the CircularDoublyLinkedList is n, it will take n time complexity. Now here again, the space complexity is O1 because here an extra memory is not required to loop through the CircularDoublyLinkedList over here. Now then we are continuing with the traversing. So in case of CircularDoublyLinkedList, we can traverse CircularDoublyLinkedList in forward way and in backward way. But in both cases, we have to visit each and every element of CircularDoublyLinkedList and print out their value to the console. Now in this case, if the number of elements in the CircularDoublyLinkedList is n, so for both cases, if we are visiting all elements, this means that it will take n time complexity. Now the space complexity is also O1 because here we are just visiting the elements through the CircularDoublyLinkedList. Now the next operation is deletion of a node from CircularDoublyLinkedList. Now when we are deleting a node from CircularDoublyLinkedList, here also we have three cases. Now the first case is we are deleting an element from the beginning of CircularDoublyLinkedList. So this means that we are deleting first element from CircularDoublyLinkedList. Now when we are deleting first element, the time complexity is O1, and similarly when we are deleting the last element, the time complexity is O1. Now when we are deleting an element from any given location from CircularDoublyLinkedList, in this case the time complexity will be n because we have to find the location. So this means that we have to loop through the CircularDoublyLinkedList. Now the space complexity for this operation for deletion is O1 because here whenever we are calling insertion method, we are going to delete only one element. So that's why space complexity is O1. Now finally, last operation is deletion of entire CircularDoublyLinkedList. Now in this case, the time complexity is n because here first we have to update the previous references of all nodes. So that's why we have to loop through the all nodes and update previous references to null. So that's why it will take n time complexity, because in this case we have to visit all these nodes over here and update their previous references to null. And then we are going to set head and tail to null, and with this we can successfully delete all nodes from the memory. Now the space complexity in this case is O1 because here an extra memory is not required. Now with this we have come to the end of this lecture. So in this lecture we have combined all operations together to see the time and space complexities of these operations in this case. Now with this lecture we have come to the end of CircularDoublyLinkedList, so hopefully everything is clear about CircularDoublyLinkedList. Now see you in the next lecture.